Welcome. I'm John Grace, and I want to thank you for taking the time to learn more about what we're doing at Enth. I'm presenting to you today because I'm the guy that built Enth. Before we get started, I should tell you that I began my career doing data science as a graduate student at the University of Chicago. Rather quickly, I found I was spending too much time on data and not enough on science. Enth is my attempt to radically alter that condition. This video, an introduction to Enth Spark, is one of a series of videos in which we demonstrate Enth working with Spark's graph frames, showcase our Zeppelin interpreter, demonstrate live joins between private ERP data and public weather data, and where we merge that data to create a custom graph database in Spark. Well, I guess I have a lot to do, so let's get started. Up on the screen, we're looking at a new type of analytic data science data access tool called Zeppelin. Zeppelin is a web-based notebook that enables interactive data analytics. Zeppelin is built around Spark, and both Zeppelin and Spark are projects in the Apache open source community. Spark is a fast general engine for big data processing, but Spark has no data. We're still required to write code to load data to make Spark work. Well, Enth does two interesting things. One, Enth has an awareness of data. The awareness is based on machine learning. And two, Enth uses its awareness of data to orchestrate the acquisition and transformation of data in Spark. In other words, Enth tells Spark where to find specific data and what to do with it. Enth is artificial intelligence for data. As I mentioned, Zeppelin is a web-based notebook. I'm using a standard version, 0.7. We use the windows or paragraphs presented here to interact with our data. Within Zeppelin, I'm using Enth Spark, a product we built that connects an Enth instance to a Spark instance. Enth Spark is available on Maven, and you can find more information on installing Enth Spark at enth.com. I'm going to start by importing a few Enth Spark libraries that I'll need. I need to connect to Enth, and I'll be using default authentication. Now we're connected, we're ready to search. And yes, I said search. We're going to search the internet for Ty Cobb's stats. Ty Cobb is a baseball player, a medical center, and many other things. Ty Cobb is also technically interesting because the results come from many data source types, including relational, open data, and even Elasticsearch. The results returned by Enth are JSON. As I mentioned, Enth is the brains for Spark, and the JSON returned by Enth contains the plan, or steps required to satisfy our request. Once the call to search is completed, and Enth has generated the plan, its task is complete. Now, Enth Spark needs to execute that plan. I'm going to start by converting our JSON plan into a set of programmable objects. I'll use Enth data frames for that. I should point out a couple things that may not be obvious. The Enth data frames constructor requires three parameters: SC, SQL context, and the plan. SC and SQL context are Spark constructs that are always available within Zeppelin. I configured Zeppelin to start a local instance of Spark. By sharing Zeppelin's Spark instance with Enth, Enth will write all data to that local instance. There are many options for running and connecting to Spark instances that are beyond the scope of this discussion. As I mentioned earlier, Enth generated the plan, and Spark is executing the plan in Spark, and our data will end up in my instance of Spark. The Enth data frames class implements ArrayList. which contains an array of nth data frame objects. Nth data frame objects, in turn, encapsulate a Spark data frame, which is functionally equivalent to a relational database table. So to make a long story short, nth data frames contains an array of relational tables. Exploiting these nth data frame objects is a key nth capability. Refer to some of our other videos for more detailed descriptions of the nth data frame object. So let's take a look at what Enth found. Let's grab the first item in our nth data frames array. I should point out here the items in the array are sorted by score, highest to lowest. I've asked for the schema, and we see we found pitching. I've asked for the schema ID. We got a score of 94, and we have some data for Ty Cobb. Unfortunately, this isn't the data I want. I want the baseball data, and I'm assuming that's at position 1. So I'm going to reach back into my array and grab the data, the nth data frame object at position 1. And now I have my baseball data. It's important to point out here that Enth accesses data from its original location, not a cache or a data warehouse. Accessing the data from its original location has two big advantages. One, because we access data from its original location, you can rest assured that you're getting the most current and up-to-date version of the data. And two, centralizing the data would require the largest data warehousing effort to date, coupled with a similarly heroic ETL effort. Enth is decentralized, eliminating the need for a massive data centralization effort. Like traditional internet search, Enth crawls the internet looking for structured data. Enth indexes that data and places that data within Enth's mathematical framework, giving Enth what we call data awareness. At this point, the plan is executed and I have my chunk of data custom built to my specifications and stored in my instance of Spark. If I want to refresh that data, I can run my search again, or I can call nth data frame refresh. But what I really want to look at are Ty Cobb's stats by year, and I only want his hitting stats. Now that I know his schema ID, I can use that and rerun my search. I'm going to reload my nth data frames. As you can see, we now only have a single nth data frame object in our array. Let me reposition our okay, now I have my baseball source, and now as you can see I have Ty Cobb baseball stats by year. Okay, let's try Zeppelin's Spark SQL interpreter. Zeppelin interpreters are interesting tools that make life much simpler for the data scientist. First, we need to register our data frame as a temp table in Spark. Due to a fundamental lack of creativity, I'm going to call our temp table Ty Cobb. Our data is now available in SQL, via SQL in our Spark instance. To invoke Zeppelin's SQL interpreter, I need to type %sign spark.sql and then my SQL. And there we have it. Ty Cobb's baseball stats within Spark accessed via Zeppelin. I can also switch over to my graph mode, and now I have Ty Cobb's home runs by year within my Zeppelin instance. So we're all in at about 8 lines of code. Searching the internet, loading into Spark, and displaying in a graph. If we piqued your interest, we do have other videos you might enjoy. Links are provided at enth.com. If you're wondering if you can use Enth to access your data, the answer is yes. If you're wondering if you can use Enth to search both your data and public data, the answer is yes. If you're wondering if you have to upload your data to Enth, the answer is no. If you're wondering if you can use Enth to securely join private sales data to public weather or private customer data to public demographics data in real time, the answer is yes. And this, my friend, is the whole point of Enth. Let's work together to put science back in data science. Thank you.